I'm Anno Saxenian. I'm Dean of the School of Information, and I am so delighted to welcome you here. Thank you for joining this panel. We are so lucky to have Mike Manoochehri here. Michael is an alumni of the School of Information. He has a Master's of Information Management and Systems, but he has gone on to do great things. He has worked at many, actually, different sort of research and nonprofit organizations, including being a member of Google's Cloud Platform Developer Relations team. And he worked on things like Google BigQuery. He's also written a tech blog, programmableweb.com. He spent time in rural Uganda researching mobile phone use. And he is now working in a startup that is, all I know is it is in the data space. So he is becoming part of that revolution that we're all sort of taking part in and hoping to play and contribute to. So without any further ado, I'm going to let Michael take over and talk about the State of Data 2014.
Right. Thank you very much, Ellen. Hi, everybody. Welcome to the DataEDGE conference. I believe I've participated in every single conference, whether speaker or organizer or just attendee. And I've seen a lot of the different sessions that come through this conference. This one is particularly exciting to me because the sessions touch on things that are personally very important to me. That is solving practical data challenges. So what we're going to do today is I'm going to tell you a little bit about what I've been doing lately. That is, I've been working a lot with data science teams that are not at large tech companies, or people trying to do things that we call data science at companies that aren't the traditional, usual suspects of the Twitters, the Facebooks, the Googles, the Yelps and the Netflix. And once you're here, it's good that you're all here, because even if you're not in this space or you're part of the, say, the MIDS program and you're learning about some of the technologies and practices and policy requirements that come in the data space, when you're in here in the DataEDGE conference, you're in the data bubble. And there's often a difference between how we talk about, how we as people who work in the data space or as data scientists talk about this technology and the policy and the implications of data technologies, and how people on the outside who are trying to solve practical problems are dealing with their problems. And I wanted to talk a little bit about that today. Last year, I gave a talk mostly on tooling. I was very interested at the time because I was writing a book. I wrote the book for Pearson, Addison Wesley's data analytics series, the introductory book called Data Just Right. And as I was writing that book, I had an opportunity to speak about tooling. I was very interested in practical implications of which tools do you use for which purposes when you're doing things around data science. And today I'm going to talk about sort of the flip side. I'm going to talk about the people aspect and what I've observed in the wild at companies that have some of these data challenges. What worked last year when I gave this talk is I opened the floor to questions and discussion, and the discussion was fantastic. I learned a lot about why some of you are here, what you're interested in learning. And so since this is the first session, about halfway through, we're going to pass the microphones around, and we'll have a discussion, learn a little bit about why you're here, what you're interested in, and hopefully that'll carry you into the next sessions. So I discussed a little bit about what I mean in the wild. What makes a company different than a traditional tech company, some of the usual suspects, right? These are companies where I think what we sometimes forget when we talk about data science or the technologies that go into data science is that some companies have been forced into these situations where they're dealing with technologies that they've developed to handle extraordinary use cases. And when I'm talking about the Googles and the Facebooks and the Twitters. And what's happening, or what has happened, is the tools that are developed in some of these companies have gone on to become more accessible, somewhat, to other people. But those tools don't often fit the exact use cases that people have at, say, a retail company, or a bank, or companies that don't fit the traditional tech mold. And so what the role of the data scientist is to solve those problems in different ways. So the first thing I want to talk about is this kind of issue we have with describing what a data scientist is, what a data science team is, and what a team that does things that look like data science looks like. So, oftentimes we talk about the data scientist because we hear stories and myths about some of these use cases. For example, we see blog posts where extraordinary insights have been developed. There's an example actually recently in the news was hey, we had Google flu trends, where apparently Google flu trends was a great predictor of flu, and then later on it was discovered maybe this wasn't so much true. And these are the stories we hear, like very extraordinary stories about insights gained through data analysis. But in reality, that's not what most people are looking at. And you're going to hear this actually over and over again today and tomorrow in some of the sessions. There's sort of a meme. It's not actually a meme, but it's the reality of what data scientists or data analysts or IT people who are doing the kind of things that we do in the data world spend their time on. And I've heard different numbers, but it's anywhere from 60 to 80% of their time is spent on data munging, like unsexy projects, moving data from one place to another. I'm very interested in use cases of taking people's technology that they use, especially legacy technology that works for them, and helping them move that data from place to place so that it can be used in a more operational way. What I mean is, oftentimes, the technologies used at a place like a bank or a retail shop use technologies that work for them really well, but don't necessarily map to the technologies we see from some of these large players, like the Hadoops and the Storms and the AmpLab work. And so what I'm really interested in is in ways to kind of figure that out. So what is happening with the data world? Why is there so much pressure? We often have this myth or meme around you'll unlock value from your data. Like, companies need to unlock value. Why is there so much pressure to kind of approach data science and technologies like this? Well, first of all, there's obvious competition. An obvious one is the kind of story you hear from Netflix defeating Blockbuster, right? People who are data-driven are winning. They're more efficient. Mark Andreessen published a very influential post in the Wall Street Journal called something like "Software is Eating the World." And basically, his argument was that companies who are primarily software companies are winning in spaces that traditionally are not technology or software spaces. I believe an example he gave was Federal Express. Like, is Federal Express a shipping company or is it a software company? Another example is, this is kind of a joke I have, but when I look at companies and I try to understand if they're data-driven, one of the first things I do is I go to GitHub and I look and see if they have any open source projects in the data space. And so I was actually thinking about this, and I was going to use the example of Walmart. Like, is Walmart a data-driven company, or is it a software company, or is it a retailer? And I don't know. You can go to GitHub and find out for yourself. But yes, that is an example of a company that I think is already in a space that's very disruptive. And so it's not only Netflix versus Blockbuster, but it's companies like Amazon versus everybody else, just driving efficiency with data-driven technologies. So that's an obvious one. We all know about that. What's less obvious, I think, to people is that companies that don't feel this disruptive pressure directly are getting pressure from other sources. So other industries have been completely disrupted by data technologies. Ads, right? Ads completely. And it's still a totally blue ocean space. I mean, there's ad tech companies popping up all over the place. There's even a few actually that's come out of the iSchool. And so what's interesting there is we see pressure because now suddenly there's an onslaught of ads data. There's an onslaught of logs data. There's an onslaught of social data. The companies don't necessarily have to deal with data in that space, but it's pressuring them to understand how to deal with all this new technology. So data science teams in the wild. A story you often hear is the kind of the hero data scientist, the one person who can do everything, the person who is a statistician and a coder and a communicator and knows how to use Tableau and writes blog posts and gives talks. And there are people like that exist, no doubt. I think the reason this term had come about, you see people like DJ Patel and Hillary Mason evangelizing this position is because they emerged. They emerged out of smaller companies that needed them. And but I think what we forget, and I think people that are actually doing grungy data science understand, is that heroes don't get the job done, right? Data science is done by teams, because basically to get anything done, you need a combination of people who understand policy and security and IT and marketing, right? And another thing I think people forget quite a lot is that we need to close the loop. So you hear of these hero stories of people who have done amazing insights, but are not able to operationalize those insights. An actual example of a team I worked with while I was at Google was a team of people at a large retailer, basically a retail marketing company. and they had taken, they'd used some tools that we developed to take weather data and mash it up with product data that they had gotten from some of their partner stores. And they got some interesting insights, like some obvious ones, like when there's a hurricane looming, people buy a lot of water, obvious. They also found out, wow, people buy a lot of alcohol, and this insight was really interesting. Then the company went back and said, okay, what do we do with this data? Like, this was a very interesting thing. It took weeks to put together because it wasn't their core competency. And so what ended up happening was they tried to operationalize this. Can we do this every day? And the answer was no. No, because this hero project was so difficult, expensive. It required a lot more technology than they had, resources available. And even worse, the cost of doing it, of operationalizing this to make it something that they could use every day, was unpredictable. Unpredictable. So that's a common risk I see at companies in the wild who are looking at data scientists, hiring people, applying the technologies that we're going to talk about in the sessions today to their projects. Is unpredictable cost. They have no idea who they're supposed to hire. They have no idea how much the technology is going to cost them and where they're going to go with it. So what's exciting about this conference for tomorrow's session is that we're going to see a lot of that. We're going to see sessions. I think Kyle Rush from Optimizely is going to be here. He's going to talk about how they use data science to build their product. There's someone from Kabam is going to be here. CTO of Teradata is going to be here to talk about experiments. And all of those sessions, to me, are really appealing because they answer some of the questions that I'm talking about now. I think the biggest thing to take away from this is that the things that people want to do in the wild, the non-Google companies and the non-Facebook companies, are exactly the same things with or without data. All people care about are what do my customers want and what are they doing, right? It's the same problem. People know what questions they want to ask. They don't need a data scientist to tell them that. They need people to help them operationalize some of these solutions. And that's, I think, where data science is going to go. What I've noticed is, I mentioned earlier that data scientists emerge. I've seen them emerge from companies. Oftentimes a person who's not in that role will put together the pieces and look kind of like this data scientist persona that we see, the person who can do it all. But in practice, to get anything done, yes, they have to touch a lot of parts of the company. They've got to talk to the IT people. They have to understand how security works and do all these things. And so I think the future of what we're doing here, like what we're doing at this conference, what the iSchool is doing with the MIDS program, is to really develop the kind of person who's more of a leader. So I think the data scientist role is emerging as a leader. There's often talk about, well, what's the role of the data scientist when technologies are changing? In the next session, I believe after this, you're going to look at some of the data science startups, which are coming out of these amazing programs at Berkeley. Berkeley's really on the forefront of a lot of these things. You have the AMP Lab, and they've got Mesos and Spark, and a large number of open source technologies, which are actually, I mean, I'm seeing them being used every day. And then you have the bids where you've got people who are like Fernando working on IPython, also becoming ubiquitous. I see IPython everywhere. And so, at the iSchool, of course, is actually developing the next generation of leaders. So what's going to happen, as I'm seeing, is that at companies that are not data-driven or have data like ingrained in their DNA, are people who come out of programs like the iSchool that are more management leadership positions. Yes, they will know how to be developers, and yes, they understand statistics. But they also know how to organize departments and companies to work together as data science teams. So that's very exciting. So concepts to ponder while you talk about, listen to the sessions and discuss with people. Data scientist versus data science teams, and some of the challenges, right, that people are looking at. And also the operationalization, like what it takes to operationalize data. What does it take to make things practical? I think you're going to see a lot of that. There's also a session tomorrow on policy, which I think is very important. And I think we forget when we talk about the exciting technologies. You need to understand security, policy, and the law. And I think we're going to see a lot of that here. So some of the lessons from the wild, lessons from what I've noticed in my work. So besides the kind of the core skills, reduction of risk. Taking data science, it's not about making the tools easier. It's also about making the tools more predictable and understandable. So you're going to see people talk about Hadoop, talk about scalable technologies in these sessions. And the thing to think about, the question to ask some of these technologists is, will a customer buy this and feel comfortable? Currently, when you go out and talk to people that are, and just any random company, they're often people that know how to use Excel, and for good reason. It's a great product. There's people that use things like R, awesome. There's lots of reasons to use those kind of tools, and they use things like Tableau. And so when another technology comes out that, that is potentially useful for them, but is hard to predict the cost of, you have to ask that question of like, how is this going to be integrated? And I've noticed many, many times that companies will go out of their way to avoid these things because they can't predict cost. I've seen companies who clearly need Hadoop to do some of their work, rather than use that, spend days running a query on a SQL server on Amazon AWS because they can predict the cost. Because when they go to their executives, they ask, I want to do this project, and the executives say, no, we don't have the money for that. I need to know how much this is going to cost me. And those are some of the problems we're seeing. And hopefully in some of these sessions, we'll be able to hear from some of the people running startups in this space, some of the companies like the Teradatas and the Clouderas that are actually facing some of these problems. And I hope that you guys get to ask some of those questions and really understand what's going on there. One more thing. I don't have any slides, but my notes from the session are actually there. My publisher gave me a few books to give away, so if some of you probably went to this website. My notes are here, but at the top there's a link. I only have 3, so there's a little form here with a pop quiz, and whoever answers all 3 questions correctly, the first 3 people to do so, I'll give the book out. What worked for me last year was, since this is the first session, I really want to get to know you guys. And so I was hoping that we could pass around some microphones. I want to hear why you're here. I want to know who's in academia, who's come outside of Berkeley. And I really would love to open the floor to questions, and not just to talk to me, but to talk to the rest of the group. Because this is a 2-day conference. You're going to meet a lot of interesting people. And I think it's really good if we kind of understand why we're here, if you have any questions, and we can have a discussion. Let's use the rest of the time to really discuss what you want to get out of this conference, what you want to see, and some other, other issues as well. So the first thing I want to ask while we're thinking about that is, how many people are here from the new MIDS program? Oh, a lot of people are here from the new MIDS program. That's great. And how many people are affiliated with Berkeley, either as students or as professors? All right. And I just want to, how many people are from outside or not Berkeley affiliated? Oh, okay. Well, it's almost, I'm not a data scientist, but it looks like about a third each. Third each. So great. So any initial questions about what I just spoke about, or anybody with these have seen these patterns before in some of their companies or companies they've worked at? No questions. All right, great. So how many people here have actually worked at a company where it's clear that there was a data-driven challenge, and the company didn't have the resources to deal with some of those things? Is anyone willing to tell me a little bit about that experience? Like, yeah, please. Happy
to speak loudly.
Yeah. Hi, what's your name?
Hi, I'm Ross. I work I'm a mid student, and I haven't started yet, but I start on Monday.
Congratulations.
Thank you. I work at a hedge fund in New York. I'm a kind of quantitative analyst who, uses lots of financial data to make investment decisions. And the biggest challenge that I've noticed is that my hedge fund's been around for kind of 25 years, and they're still using data techniques that were around 25 years ago, and kind of trying to band-aid new techniques onto those old things is a gigantic challenge that they have.
If you could pick one pain point, what's the biggest pain point they have?
Have you ever heard of FAME?
No, the movie?
Yeah, that's not good. Because that's the database system that they use. FAME is probably and they actually, FAME actually, is a legitimate a company that still exists, but they're using a 15-year-old version of FAME.
Yes.
Because they cannot afford to update to the new versions because they have so much built into the old versions. So, I don't want to offend anybody here who may or may not work for FAME, but
if somebody here works for FAME, I'm glad they're here.
Yeah.
Because
yeah. So it's the implementation of FAME at my company that is probably the biggest problem, and we
so this
can't
reminds
free
me,
ourselves from the old.
Right. I just actually talked to someone who has exactly the same problem. This person is typical of what I see a lot in industry, which is a person who understands the question they want to ask and is stuck in a situation where she wasn't able to find a result quickly. Like there was no obvious way to do this. This was her problem, similar to yours. She had a lot of operational data that was coming from a web front end. Right from it. 10 years of this data, just like your problem. And they used it, they were on SQL for good reason, because relational databases are great for front ends and operational data and retail. Of course, the consistency model is there as well. But what she wanted to do is ask these huge questions. She wanted to ask, and questions that these aren't insightful, questions. These aren't like hero questions. She was wondering, which of my customers buy this and this together? It was basically a question like that. The same question she would always ask. And she was stuck by the technology. It was basically the database. The biggest problem she had was the database being used to collect the data was the same one she wanted to query against. And it was always too busy to run these massive queries. And it couldn't even handle them anyway, right? So this is it sounds ridiculous, but this is the kind of problem you see outside.
Yeah, I have a very specific example. So I work on a 4-person portfolio management team, meaning we manage our own investments, and knowing how our portfolio is doing is something that's extremely important, right? And we want to be able to try to correlate that with prices of different securities, et cetera, in the market. But I've been waiting for a year for the ability to do that because they can't get the authentication. So security is very important. Yes. They don't want anybody able to see our P&L and vice versa. So they can't provide me that data because they can't. It's been taking them a year to get the authentication in place.
Yeah. So yes, and this is another pattern, right? Like people often talk about data science or these kind of data science teams of having free reign over the data, but there's lots of good reasons why not. Why not? And so, you need to include IT. Like, IT is very important in these situations. And I think in this bubble that we have, we're going to talk about, oh, it's so great to use big data to do this, or use big data to get this insight, or make this money, or make the best game ever, or make the most frustrating game ever, like Flappy Bird. And like, but this is a common problem, is like what data scientists need to be learning is how to solve that problem. Right, which is arguably not a problem. I'm glad there's high security there, but it's also the question of how do I make this a real project? I need to ask a simple question about my data set. And so I think what we're going to see is data scientists emerging more as managerial leaders in this situation where they come in and are able to figure out some of these problems. Now, it's true that this is an operational problem, it's an organizational problem, whereas whatever company needs to understand that this is important for the future because of all the competition I mentioned and the disruption. But at the same time, you need IT. There's no reason why you have to throw away all the technology you have if it works well for you. And I think that's the mismatch I see from people who use technologies developed at the Twitters and the Facebooks applied to other situations. Because yes, of course, Google and Twitter and Facebook all use relational databases and web front ends, but they're able to get away with different types of technologies. For example, the consistency model of a non-relational database was necessary because of the high volume of data streaming into these places. And and of course, those companies have teams of engineers. Everyone talks about how great Google's data processing is, but don't forget every single person that works there is able to express concepts in code that allow them to do things and shuttle data back and forth between different systems. None of that is a huge challenge when you throw 20 engineers at it. But in your case, I'm guessing that you don't have that capability.
Yeah, IT is pretty stretched at the firm. Yeah.
Right on. So yes, so this is very interesting. So keep those questions in mind. I think what I'd love to see is when you go into the next sessions, when you see people from Teradata and people from Optimizely and people from Kabam, ask them some of these questions and see how they got around them. Of course, some of those companies started with software engineers from scratch, and they probably built some of these ideas into their systems. But these are the kind of challenges I think that in this conference will help us understand the best practices for, which are still being developed. Cool. Anna.
So I have a question which I'm sure is a classic question in many older organizations like yours. UC Berkeley, we have data that is collected in many different silos. So we have data from our registrar, we have data from our financial systems, we have data about course scheduling, but they're all separate, and they don't talk to each other. And and we are stretched very thin financially.
Yes.
So I suspect that's a problem you see often in other organizations. How do you think about that?
So I have a perspective on this and an opinion. I talk to people all the time. I think it's kind of a 80s, 90s, 1990s kind of opinion of warehouse everything. And I'm glad that we have technology. There's another perspective now, and it's sort of this maybe Hadoop everything, right? Like pull it in when you need it and process it. I believe that people should use the data stores that are best suited for their application and deal with it another way, right? So I'm more on the side of like, don't warehouse everything. Don't worry about the data warehouse model, the star schemas, and all these kind of technologies you see to make it all go into one place. But I think we lack good tools to do what I'm talking about, which is to get data in a place where it should be. And you'll see that. I mean, Trifacta is going to be talking soon. They do a good job of this. There's companies that are attacking this problem in different ways. You see companies like Keen.io attacking the streaming problem. So just stream it in somewhere and process it on the fly. But I think the main problem here is that it's little things like things like schemas, right? Schemas drive me crazy. So I worked on a project where I was taking data out of a non-relational data store. I was putting it into HDFS to process with Hadoop using Pig. Then I would take that data and put it into Google BigQuery for analysis. And then I think I was sticking it into a relational database for a front end. It was a Google project I was working on. Each one of those steps, I mean, this is the kind of 80% data munging problem we're seeing. Each one of those tools expresses schema in a different way. Right? And I know it's trivial and there are tools to help you, but this is the kind of thing that data scientists have to deal with, right? A schema-less system going into a strict schema system, going into one that's a little looser, going into one that, again, strict. And this is the kind of thing you need a developer for generally to deal with, right? And that's the kind of tooling that I think is missing. Like we're missing this really important aspect. And I think the problem is people aren't looking at practical use cases enough. Right, we've got, and for better or for worse, the tooling that we have has grown out of mostly specific use cases, right? I need to collect data at web scale, so I need a non-relational database that's always available. Or I need my data to be really locked down and consistent, so it has to be a relational database that may be not as available, but it's very consistent. These are different use cases. Problem is, to solve these end-to-end problems of asking these questions, the kind you're talking about, Anno, currently requires multiple technologies, and they don't match very well. And I think people aren't looking, and this is something I think we need to talk about as data science people, ways to make that easier, right? And you're going to see, I mentioned a few of those companies, but you're going to see more and more of the companies stepping up to solve some of those problems in various ways.
Hi.
Hi, how are you?
I've got a rather unusual problem.
Sure.
I think it's more administrative. I'm Jim Lola.
Nice to meet you.
So my environment is a research environment for a company. Mm-hmm. We do a lot of work on GPU clusters. And then we have this large system called a D-Wave quantum computer.
Ah. Is it a real quantum computer?
Yeah, we've been running it for 2 years.
Cool. I love that.
It's probably the only one that is running right now.
Right. Very cool.
So we've been doing a lot of work with R.
Uh-huh.
And a version of R that's been hacked specifically for the GPU cluster. Our D-Wave uses MATLAB and Python. Mm-hmm. Both kind of make me cringe.
You can run Python on a D-Wave quantum computer?
Sure.
Oh, that's cool. Great.
Why not? But what we're trying to do is we're trying to get some of our analytic algorithms that are in R over to the D-Wave. Mm-hmm. So, we've done a couple things like take the code that's in R, port it over to Python, and then get it to run, but then you have to take into account some of the weird things with the D-Wave, like the Isling effect. So our biggest problem really is to use or find someone at either USC or within our company that can do a port of R onto the D-Wave or a port of Julia onto the D-Wave.
Yeah. It's so interesting. I actually have a chapter in my book about this very problem because I contrast Python and R and talk about the kind of the challenges. So R is great. R has a huge community, and it's the libraries that are great. What is it called? The CRAN, I think it's called. The package is great. You'll find more Python developers. Python can be run in more places. And when you're building applications, I'm actually working on some software now, and it's primarily Python, right? So I use things like the Pandas library. I use IPython. Everything's Python because it's just easier that way.
Yeah, those libraries don't work on the D-Wave.
They don't use, okay, that's what I was wondering. So this is an interesting problem. So I always advocate to use the tool, how do I put this? Use the more general tool that has more developers in practice because of this problem, right? Because you will have domain-specific people using R and people who, you can find Python programmers anywhere. And even though the libraries aren't quite maybe as good yet, they're getting there. PyData is really good. These problems pop up all the time. And so I think you're in this interesting bootstrap problem where I would suggest like dumping R in this situation. If I was like the CIO, I would say like, look, we need to get rid of R. As awesome as R is, I would only use it in a production environment if I knew everybody was a statistician. Like at Google, stats team uses R through and through, but everybody there is an R person. They don't need to do anything else with the data.
Well, our algorithms that we use are in a production environment. Mm-hmm. It is a production GPU cluster.
Yes.
And what we're trying to do is we're trying to figure out whether or not these types of algorithms would work well on a D-Wave quantum computer. I mean, that's the problem.
I guess my question is like, what kind of developer resources? What do you have?
Graduate school folks from USC.
Yes. a good computer science school, but
we've got an agreement where we bought the system and they're hosting it, and then we have developers from all over the United States. Mm-hmm. We don't use GitHub from an intellectual property standpoint. We're not permitted to put things out onto the public GitHub area, so we can't leverage that community. Mm-hmm. But we have probably about 10,000 programmers across the United States.
Interesting. So your problem is not language specific or technology specific, it's algorithm specific.
Right.
That's very interesting. Yeah, I actually have never heard of that particular problem, but that is very challenging. And I can see that this sort of mismatch between the two. It almost sounds like you need an algorithm specific language, something higher level to share things between the two.
Sure.
But interesting problem. Like yours is very specific, but I've seen problems that are very similar to yours. And I think, I think what I want to see from people that graduate from like say mids is an opinion about this stuff, right? It's not just about, oh, there's R and Python and now all this stuff is great. It's like you go into the industry and you need to say, I'm using this because. And I think that it's a tough spot that you're in, but like it happens all the time on smaller scales everywhere. Like people have to choose the right technologies for the job and understand it. And I think that's an important role of data scientists now. It's not just, I've solved the problem once. It's like, I need to build an organization that through and through can use these technologies in the proper way. But yeah, we should talk, I'm interested a little bit more in your work. We should talk after the session. Excellent.
Hi, my name is Mana and I work for Teradata, but I don't do all the smart stuff that our CTO is going to talk about. So my question to you is about the organizational alignment for the data science teams. So where do you see these teams within the organization? Are they part of IT or business, or what are organizations doing?
Yeah, I have some examples of that. I work with an organization that has the data science person is not called a data scientist, but he fulfills that role. And his role is more in the BI, I guess they call it BI, business intelligence. But his role is separate from the IT staff, which is unfortunate. I think that's an unfortunate situation. I sort of ideally don't see data science as sitting in one camp or another. I feel like to compete, eventually companies will just, that has to be part of the through and through organizational kind of concept. But I definitely think that if that's not the case, then the data science team needs to be very close to IT. I think that I think that's central, and I think that IT, like the people that IT means a lot of different things, but it's the people that run the servers and the people that care that they're running and the people that deal with security, that kind of role. That's very important to the kind of work that we all do or we're really interested in here. So I think that unless there's a better, better to have the organizational be very data driven and understand that. But if that's not the case, then I think IT. Even better, I think, is for the company to understand how to build its own tools or use tools where people can get the data they need at the time they need it. This is a common, this goes all the way back to the 1958 paper by Luhn. He was an IBM scientist, L-U-H-N, and who coined the term business intelligence. And he did this sort of Vannevar Bush-esque essay about how he would see what the ideal business intelligence system would be. And it would be a system that on demand would drive to the employee the data they needed at the time they needed it. Right? And that's kind of still sort of the case. Now we can actually build some of these systems. What I talk about in my book is that it's interesting. These systems have started to be built for consumers, right? The idea that I can walk down the street and my phone will let me know, there's a coupon for a store that I like anytime. But we haven't even come close to doing that for internal organizations. And so I think that is a good ideal to strive for because that's what a data-driven business really should do. If I'm an employee who's in accounting and I need to know some kind of information that will make me more efficient, there's no technical reason why I can't have a tool that lets me do that. But there's operational reasons, there's policy reasons and security reasons. I think that's the kind of tool we need for organizations to make them data-driven. At Google, we internally had a lot of these tools, but they were more ad hoc, right? Like I had access to tools that would help me look over things like this, are the servers running properly, right? Like I could do that. There were tools that let me do that. And that's kind of what a data-driven company is all about. It's like when I need to have access to the data to get my job done, I had those tools. But outside of those big companies, the Twitters and the Facebooks and the Googles, there's not a lot of that kind of tooling that I think is effective. So that's what I'd love to see more of. That was a really long answer to your short question. Yes, the question down here, or comment.
So I'm working for Kaiser Permanente. The IT. Sure. I'm working for Kaiser Permanente within the IT department, and I'm seeing similar issues within our organizations. Right. I think part of it is KP is a pretty complex organization. It has some entity that has the medical doctors, and a separate entity that has the hospital and IT, and then yet separate entity that deals with the health plan part of the organization. And
just a question. I know some people that used to work there. Do you have a dedicated data science team at Kaiser, or data team?
So what I've seen, and I'm still trying to learn where are all the pockets, because there's so many different pockets, like what you mentioned as well, I think, because within the IT itself, there is some data analysis, data governance, that is interested to do some more analysis. On the TPMG side, which is the medical doctors, they have several divisions. One of it is division of research, which does a lot of analysis on patients' data and how to improve the healthcare side of things, right? And then on the health plan side, also there is some BI-related activities. So yeah, I'm one of my question is similar to what the gentleman raised.
What is the, like, if you pick one thing that you would improve for the Kaiser customer, what would it be? Like, what are you trying to accomplish as an organization?
Right now, there's a couple of focus. One of them is to reduce costs. That's one of the big thing, and then also to improve efficiency, right?
And the biggest pain point is just that to do those things, data is just strewn about everywhere, and people aren't communicating probably. Is that not right?
Yeah. So we have patients' data, obviously, right, from all of our patients' engagement, but there is also a social aspect that and behavior aspect that we want to integrate into the BI system and do overall analysis. And there's some research around how our members' social and networking behaviors might impact their view of healthcare, how they take care of themselves from the healthcare point of view. So we're interested to learn that.
Yeah.
And obviously, two different set of data that we need to combine, right? And then we have an internet site, kp.org, that also collect various data within from our members, right? So that's yet again different part of the organization that has those data and collects those data, and we have a marketing data or groups that has BI related.
Let me just note something. Like there is a technical problem here. Like these are technical problems at IT, but it's interesting to note that except for the D-Wave quantum computer Python R problem, these problems are not technical. I've not heard anyone say the word Hadoop or Spark or Mesos or any of these things, and it's very interesting to see. Like I think we're going to spend a lot of time in the DataEDGE conference talking about things that have nothing to do with specifically about technologies, like very well understood technologies, and these problems are completely organizational.
Right. I mean, technology is definitely part of the challenge, right? Just to decide which technologies to adopt within the organization, right? Because every department would have their own view.
It sounds to me like your problem reminds. It's going to sound totally different, but a problem that I've had. Another thing I did at Google was like Internet of Things development. Like interested in that project. So think of like Nest, machines that generate data. And the question I always asked was, how do you verify that a piece of data that came from, say, a sensor that was connected to the internet or a toaster connected to the internet was like what are the permissions on that chunk of data? Like how do you say this toaster is, the data that comes from this toaster is authorized to me, or the data that comes from my car is authorized to me, and how do I verify that? Like nobody ever talks about these kind of protocols, and I think what we're missing, I love these conversations because I realize like some of the things that we need to build. In your case, like it's not about, the technologies are well understood. I'm sure the technology exists to make the data problems of kp.org go away. But what you're missing is things like, how do I manage security when I'm throwing data over the wall back and forth? Or why are there walls in the first place? And if there are no walls, how can I make sure that the data is secure? You're in healthcare and you've got tons of, I forgot all the names of the compliance that you're dealing with, but that is a huge problem for you. Right. And so it's interesting like to know, like if another thing to ask some of these people that are going to talk about technologies is how do they deal with some of these security and policy issues? I think there's actually a policy talk tomorrow that'll be really interesting to see. And I would actually ask some of the venture capital people on the panel that's later this afternoon how they see this problem. Like, is this something they're investing in? Is this a problem that they see, is there leadership being developed? Or hey, are the mid students learning about this stuff? I think these are really interesting questions. Maybe let's talk a little bit more too. Like again, like your problem is just like this other problem. It's a very daunting organizational problem, but I think it's very common for organizations your size.
So it says that you've worked with a bunch of smaller organizations and nonprofits, and I was wondering, a lot of people use data for sort of the typical uses like advertising and marketing, and then like understanding your user base and making sure that the product is it continues to grow and you maintain the user base. But I'm specifically interested in nonprofits, but also for the smaller organizations. Are there any interesting examples that you can think of how people are using data? Yeah, this is going to sound weird, but I love it when people use data to reduce the size of the organization or make it completely irrelevant. So like I used to work at an anti-hunger nonprofit. I'm not saying that was an irrelevant organization, but our goal was to do things like get the word out about things, and use tech. We were like basically a publishing house, and when I joined, what I was looking for is like ways to engage customers better. And I've seen that in some cases, like if you think disruptively about the technology you're using, sometimes you don't need the nonprofit anymore. It depends on what you're doing. Like nonprofits can be research orgs, they can be advocacy orgs, they can do all kinds of things. And I like it when people use data to like here's an example. We were always trying to get the word out about hunger, like how much hunger there was in the United States, in California, like count numbers and things like that. It was a think tank. But wouldn't it be cool if we could do more with government data, with the data that we have, and make it more accessible? An example is, I said this last year too, the census, the US Census is terrible at their data. They do the exact wrong things, I think, when they're trying to share data. They use XML, which is a document interchange format. It's great. XML is wonderful. It does its job, but it's not great for making an API out of. I think they have an FTP site where you download the stuff from. Like that thing's going to fall over when 3 people hit that site. I mean, everything is wrong that they do. And I think those are some of the problems I think our organizations, the best practices there are not being followed. I'm sure lots of research organizations are doing that. And I think what is helpful, my opinion is the people that work here, and we really need people from the iSchool to go out and do things not just in industry. There's been a lot of startups coming out of there, but also in research and nonprofits to help people understand, like, if you want to get the word out about something, maybe what you need is an API, or maybe you need a way to share the data, or maybe your site should just be a bunch of
pie charts that tell the story. And how do you tell that story? Like go to the CS lab here at Berkeley and have some of the best visualization people on earth. Like learn from them and tell that story better. And maybe you don't need to have 12 people on your staff. Maybe you just need one person with a website. I'm being idealistic, I realize that, but I mean, I think that's where some of this technology can really help doing those things. So that's how I feel about that. All right. It's so quiet in here. Is everyone having fun? I hope you're having fun.
Yeah, I'm May. I work in financial industry, also in quantitative investment. So we're kind of interested in the big data as as you mentioned, the competition is there. So we already want to stay on the edge to we make sure we're kind of winning the competition. So I'm kind of just wonder if you can elaborate your point that unpredicted cost, because we are also like. Today, we just had a meeting about the technology. We're seeing in a company, some will complain the technology is old, Unix server is old. Then you understand how much it costs it is. So if you spend a certain money, you buy a new Unix server, or if you want to change our SAS to R or to Python, that's 6 months of time.
Yes.
But why you are saying that the data science is an unpredicted cost? I just wonder if. Just kind of for us, like for example, if we want to invest in big data-driven signals, then how much investment is that, and why is unpredicted?
Yeah, very interesting. So I'll give you an example. Maybe I said something about this already, but I talked to a gentleman who knew what problem they wanted to solve. So in your case, I think you're weighing different options and trying to figure it out. The wild card was two things. It was, what am I going to get out of my investment? I think this person was going to set up a Hadoop cluster to slam through a bunch of data. They were going to analyze it. I think what they were trying to do was crunch it into a shape that Tableau could use. Basically, he wanted to provide reports to the executive about I forgot what it was, something about sales. He knew he needed Hadoop. He didn't know how to build this cluster. It would be something he could do if he spent 6 months learning about it, or he could hire somebody. Then he realized he needed to hire someone to write code for that system. And maybe that's the same person, maybe not. Already that's unpredictable cost, right? And the biggest problem is, how do you know what you're going to get out of it? Like, if I have terabytes of legacy data and I need to ask these questions, I might ask questions and get no response, and I've spent $100,000 plus 2 engineers' salaries. And so these are kind of the problems that you see. When you use well-known technologies, you said you probably use SAS and you're using other things that are well-known, an IRIX server. You know exactly how fast that server is going. You know exactly what it takes to run a query, and you know how much it's going to cost you. And so what I see is like organizations will almost always veer toward the old, broken, FAME database or whatever, because they know how much it's going to cost. And I think especially in academia, like we have to recognize that. When you get out into the real world, it's like, that's a big problem, and we have to solve. The way to solve it is to help build tools. I mean, as a technologist, I'm not saying for your use case, but as a technologist who are building this stuff, is to say, this is how much it's going to cost. I've done this before. Here's my use case. I know how much this is, and I know I have a service that does this, and to actually solve these use cases. In your case, I think you have to weigh what is the, how do I put this? Where are you trying to go? Just like I asked the gentleman from Kaiser. Where are you trying to go? Is your pain point that you have so much data and you feel like you're falling behind on intelligence? Or is the problem that you just feel like the computers are getting old and you need to keep up because you need to buy new computers? Like, what is the actual pain point that you're facing?
I think, like, for example, we're talking about social media sentiment, for example. But then, how do you entangle the data? How much technology do you need to invest in order to entangle the data, in order to get some juice out of it, some information out of it?
Yes.
There are lots of data out there, and so much, and so many, and then I just wonder, like, is there any maybe technology already exists, third-party tool already exists that help you to kind of get the information out?
Yeah. I mean, I'm not advocating any particular product, but I do know like companies like DataSift do that work. I would actually look at a company like that. There's others that do it because you brought up an interesting one: sentiment analysis, social media sentiment analysis, complete crazy black box. Like I think that's a very hyped up place where I've seen I've seen people try to guess the sentiment and then realize, oh my God, my sample size is skewed because people usually post when they're ranting and they don't post when they're happy. And I think that just be able, I've seen, like, you probably have all seen this too, studies where sentiment analysis is, I'm very skeptical about it because I think there's not enough statisticians really explaining what's going on in some of those studies. So again, like, that's not something I would do in-house unless I had somebody I knew I trusted could do some of that statistical analysis and really understand it. In those cases, but the tools you're asking about, and I gave dataset as an example, are the type of tools I think we need more of, because I think we need somebody to figure out, is this a valid, viable option? By the way, tomorrow there's a talk, I believe it's called, I can't remember the name of it, but it's about the viability, the economic impact of some of these big data technologies, and that's one that's really interesting. I think you should definitely go to that one if you're around tomorrow, because I think you can maybe ask that question and get a sense from that panel how they feel about your problem.
Thank you.
Sure. I have two questions here. Hello.
Hi, my name is Janik. I am an economist. For the last several years, we've mostly used Python to build sort of economic and financial models. Mm-hmm. My observation is, again, fundamentally organizational one, about the nature of small and poorly resourced organizations versus large and well-resourced ones, which is that my own experience, at least, is that you can often do much, much more, in fact, orders of magnitude more, on your own or with a small team in a small and poorly resourced organization than you can in a large, well-resourced one with a big, established IT bureaucracy.
Yes, interesting. I had this observation in my notes, is that oftentimes when you go to big companies, actually why I asked the person from Kaiser, the data science teams tend to be small. Like, even if you go into a large organization with like a huge ID department, when you meet the people that are doing the data scientists, they act like a small company within that company. That's very interesting. Is that what your experience is?
It's particularly so because I used to work for a 150-person worldwide global consultancy. We wanted to build a bunch of stuff. We had no one to do it, so we taught ourselves and built something that worked very, very well. During last year, we got acquired by a large multinational firm, big established Microsoft Visual Studio shop. No open source software tolerated.
Yes.
And suddenly everything we had done was going to be replaced by another team that was trying to do the same thing but hadn't yet figured out how to do it, and very clearly was going to take several years to get to the same place.
So every time you had a problem, you just throw developers at the problem and then
exactly.
And then do it again when it's deprecated. Yeah. Interesting. Yeah, I mean, that's an interesting problem. I guess my question is, I guess why? Like, why was there no innovative thinking inside? I don't mean to say you weren't innovative, but like, why was that the case? Like, why weren't people throwing, like some of the technologies I mentioned earlier at some of these problems? Why recode everything?
Overwhelming belief, I think, in standardization, and that somehow when you had a bunch of .NET developers, they would never ever be able to do Python or anything else.
Okay.
And so this stuff could not possibly be maintained in the future, so we must redo it all.
Very interesting. Yeah, my reaction is always like, it drives me crazy when that happens, because it's so, you see it happening. You're like, this is not the right way to solve this problem. And maybe this is a good lesson, is I think this is the reason why the data science teams that have to do these interdisciplinary, cross-department work, where they're talking to IT guys and saying, hey, like, I need to access some of this data, and then going to the marketing people and say, hey, what do you need me to do with this data? What questions are you asking? Have to be small, because they have to be nimble and be able to use technologies that the rest of the company has no core competency in. It's very interesting.
One brief example of that, for instance, is when I started talking to some of the developers in this company, they were very jealous that I had Git on my machine because they weren't allowed to have that.
They weren't allowed to have it, yeah. That's interesting. Cool. And there was another question right here, yes.
Hello, my name is Paulo Isler. I'm building a real estate and financial markets lab at the Haas Business School.
Oh, interesting, yeah.
And I started this, a few months ago, about 7 to 8 months ago. So you're still learning and doing there. My question relates to the limits of the traditional relational database, and I'm basically, having that question on the back of my mind for a while, because we have about 10 terabytes of data, economics on real estate and on the financial markets. And at this stage, it's very primitive in a way, because all these data sets, they're on flat files, that that our scientists will have to build up their own data sets out of this, and it's very hard to relate one to each other too. So I've been on a pilot project now, implementing, moving that data from this primitive, fashion into something bigger and better. And in this pilot project, I'm putting together a relational database to accommodate these 10 terabytes.
So that's quite a lot.
And exactly. So this comes my question now. What are the limits on the traditional relational database? Of course, this data is not transactional. There's your example, of this retailer that have, all these OLTP activity going on all the time. We don't have that there. It's more like a business intelligence, static data sets that we own. But again, when is the time to divide and conquer, basically?
Yeah, the answer, well, there's good and bad news about that. But the question I would ask is, what do you need to do with the data? Is it querying, on-demand querying?
Yes, there'll be a lot of ad hoc queries that would run, basically to extract, is a lab. So you're running experiments on this economic data. So everything goes in a way. Another important aspect that we want to do there is to provide opportunities to relate these data sets. Because that's where the interesting research questions would come, and so these are the critical elements that we're trying to address.
This is, sounds like on the surface, you needed a class of database called an analytical database, right? So you're looking at, like Impala is a good example of that. You can build something like that using the projects that the AmpLab have with Spark. The idea being, you probably have a static file that doesn't change much.
Exactly.
And it's append only. This is a project, like Google BigQuery was like that. It's a database that's optimized for ad hoc querying, very fast ad hoc querying. And when you do that, you throw away a bunch of other things. You throw away the ability to do transactions. You throw away the ability to delete even a single row because the data set is static. But it sounds like you do this once, you get it into your database, and at worst, you might want to append data every month, or something like that, or even daily.
Even less frequently than that.
But the relational question, so there's two, and the good and bad news. So the bad news, I would strongly suggest not using a relational model if that's your main use case. But the good news is there's a convergence, and people are thinking about this a lot. You see, I still think 10 terabytes is a lot because I don't know what kind of hardware you have or what kind of budget you have. But there are projects that are trying to improve the traditional limits of relational databases. I actually had this very interesting. I had the exact conversation last night with one of my engineers. We were discussing. I'm using a non-relational database for something, and he was advocating for a relational database and blah blah blah. But in your case, there are lots of technologies coming out where people are building distributed relational databases, like MemSQL comes to mind. That's a very interesting project. VoltDB is another one. That's a very interesting project. These are relational SQL compliant databases that are designed to be able to query fast and also to scale. So as you can throw machines onto the cluster and they'll scale tremendously. But I think if you're decided that you don't need any of the consistency, or you need consistency, but you don't need any of the transactional capabilities of the traditional relational database, I would strongly suggest looking at an analytical database, and there's a lot of those as well. Teradata is another example. I would use something in that vein rather than something like a SQL SQL Server or MySQL or even a distributed version of those.
We're as we speak, we are trying with Postgres.
Postgres can be scaled up, but I think I'm guessing, I don't know your hardware, but it's the performance. Like if you want raw performance over that data set, you decide, I want to ask what the sum of this particular stock's price was over the entire year. That's going to take, I'm guessing that will take a long time on Postgres. The indexing you'd have to build to speed that up would be very difficult to do. So I would look at a very specific, these analytical tools and check it out. I would look at Impala, for example, a tool like that. So yeah, and again, we can talk later outside and we can discuss this more. This is very interesting to me, the kind of tooling problem.
Sure. Thank you.
Hello.
Hi, is it me?
Yes.
Hi. My name is Heather Umberger. I've been coming to DataEDGE for about 3 years. I started my data-centric company about 4 years ago, so it's a good fit. And what I found, I had great ideas when I first came and started building data solution products. And what I found is, gosh, I think we're consulting with about 50 different companies now, so we've had explosion. What I'm finding, the #1 issue is territorialism.
Is what?
Territorialism. People within organizations who they're data hoarding. I think it has a lot to do with job security, and it's scary. There's no fix for it. It's institutional. It's a systematic problem.
Who feels this most scared? Is it IT?
You know, I think it's kind of analysis paralysis of data. So where you think you're focused on analyzing on the big level, it's actually the fear of analyzing and realizing that you're not of value.
Interesting.
The
implications.
Yeah, and I think people just don't want to volunteer their data, their perspective, and there's fear. And I see it a lot. It's
interesting.
Massive.
So you were down here, we were talking about efficiency for Kaiser. It's like, what if you find out that 10% of your workforce is redundant or for some reason?
It's not, you will find out.
You will find out.
Yeah. It's actually, I think that's the scary thing is we realize that advanced analytics actually replaces humans. And how do you don't want to be the decision maker that puts people out of business, out of work. You feel like a jerk. But you're spending money to do something that the human factor could be used elsewhere. So one of the big things that I do is try to help businesses figure out how they can take their human expertise and use it to leverage better business decisions. So not replace the humans, just use them better. That's actually
That's fascinating. Every time I come to the DataEDGE conference, I always have like 3, I wish I was a student again, because I always think of 3 like final project ideas that I could explore. And this is an interesting one. It's an anthropological study, right? It's like listening, I mean, you're doing this already, but like listening to how people talk about what data is all about, and like, let's talk about that. This is a big issue. And I think this is, I mean, we talk a lot about data and the implications and the myths and how great it is, but these are the real problems that we're seeing on the ground is like, people want to be more efficient, and they're realizing, oh my God, I'm going to lose my job, or somebody else is going to get fired. Like a real human issue that we have to talk about more.
I think it has a lot to do with job security being based on redundancy rather than innovation. If you kind of challenge yourself and make yourself think differently, it's not really a matter of can you be replaced. You will replace yourself with something that you came up with, and then you can get on to bigger, more interesting problems. But we don't have that mentality in business, I think. I think in academia we do.
And just a quick question, like as a follow-up, do you help people figure that out? I mean, have you been able to do that in your work?
I have, actually. I think one of the things coming in as a data science consultant, computational scientist, is you come in and you kind of have the keys to the kingdom. They trust you a little bit more, and we should leverage that as a community, which is corporations, businesses, whether they're big or small, trust you to kind of go across all of their silos and knock them down.
Yeah.
And I find that 90% of my time, this is horrible, is spent just talking to people about their data, asking them what questions they need answered, what questions they're answering, what data they have, what data they need. We've become kind of a data broker in that sense, but internal within a company as opposed to outside.
I have a flip side of that story where I heard a story about somebody I was working with who's very good data scientist, like great. It fit the model that we were talking about where he had a team of people under him that were very sharp, and he was doing all these cool things. And I'll tell you another story about him after this, but that company had this new VP join. And the VP wanted to show off. I'm worth it. I'm worth the big money that I'm getting paid. And decided to, like, while this team was there, spin up his own team, or to solve his own projects in this other way, basically creating redundancy for sort of the opposite, to like prove this was, he was valuable. And I think these are really important problems. And in some ways, in some companies, you have things like HR and people departments that help figure this stuff out for human resources things. But it would be great if we had people that would apply the same thinking to the efficiency of organization of data, where you could say, like, this is ridiculous. This is wrong. We shouldn't be doing this. We have a policy against this, and solve some of those problems. But I think, of course, like, this is a much bigger issue, and I think this is really interesting to talk about and think about.
I think territorialism runs rampant out there,
Yes.
and we just don't want to share it. It's data hoarding, and it's a horrible thing.
Right on. Yeah, very interesting. Just a quick time check. Are we good on time, by the way? OK, good on time. Any other questions? This is a really interesting discussion. I love this. There's a question back here in the corner.
Hello.
Hi, how are you?
Pretty good. So I'm a software engineer and been doing that for like a few years now. I work for this really tiny startup. We're doing really well. We're collecting all this data at our users, like just tons and tons of data. And we're like a developer house, and like everybody there is a developer. So, and I'm really interested in data science. So basically, I want to figure out how I can leverage the data that we've collected to enhance our products and get more users, things like that. And so basically, what I'm interested in right now is what, like, from somebody who knows really nothing about this outside of like the computer sciencey, like theoretical type of stuff, the technology, exactly what should I be looking at right now?
I would never start with the technology. Like I would
never.
What's your question? What's your question?
A lot of questions.
Or questions.
Okay.
Or, I know it might be proprietary, but like, what's a question you want, or what do you want to improve? Like, what do you not know that the data might tell you? That's what I would start with. Like, for example.
That's interesting, because usually I have like an open-ended type of way of looking at things. What, like, if I work on this, then what does it tell me versus what do I want to pull out of it?
Like, what would make your product better? Like, is there something you could ask?
Yeah, interesting sentiment analysis could definitely do that. Our user base, it's a messaging service, but the type of messages that they send is between students, parents, and teachers. And so because of that, it's a very defined and very specific domain. And so we know that we're not going to get ranting, hopefully, over that kind of a channel. So with that, sentiment analysis would be really interesting.
There's, depending on how, like this data also is generated by people, and I don't know what the data policies are around that data, but, interesting questions to start would be, I would say, like time. Like, when are people doing things? Are there reactions to things? Are there things in the news that cause a reaction? Or, are there ways that, those are easy things to start. I realize it's hard to know exactly what it is until you've looked at the data. But I would never even start to think about technology until you've actually thought about some of those questions. And I'm guessing that whatever thing you've built, if you're handling this kind of like large load of chat messages, can probably be easily used to it's an easy system to put in something analytical, like an analytical database. But I would never, ever start with the technology. You will find the technology you need, and it all is out there when you figure out that question. Right? Like, I think, for example, you mentioned sentiment analysis. I was talking about some solutions to the other question about how do you deal with sentiment analysis. And I think the first thing to do is figure out where that data is coming from. Like, where's that sentiment coming from? It has nothing to do with the technology. I would never build anything first. I would always figure out, like, what am I trying to ask? And if you do need some of those technologies, they're easily accessible. You're a developer, right? It's a developer's world right now with big data. And unfortunately, like most of the tools that are, I think, really cutting edge are just developer tools. Non-developers can't handle them. And I was actually talking to Anno before the talk about what's a data scientist going to look like in 5 years, right? And like, how much code is that data scientist going to write? I don't know. Maybe there's new things that will require some coding or some, And right now you need it. You have to. You can't query your data on some of these analytical databases without knowing something about user-defined functions, or it's hard. And plugging them together is a nightmare. And so you're in a good position. But again, sorry, I'm kind of going off on a tangent, but it's all about the question. Never start with the technology. The technology is out there. You'll find it. The guys at the App Lab are building it, and the guys at the BIDS Lab are building it. But you have to know what your question is before. Otherwise, it'll be a wasted investment.
Cool. Thank you.
Great. Other comments or questions? Anything else? Yes, there's one down here.
Hi, it's kind of a follow-up to what you were just talking about right now, which is basically to solve some of these data or data science challenges, you kind of need to be a developer, right? But for example, I work at Lawrence Berkeley Lab, and the people who have the questions are the domain scientists. So do you see a movement towards enabling the sort of end users or the domain experts to be able to answer their own questions with the tools?
Yes, I mean, I see that. Anecdotally, I was looking for some stats around this, but yes, I think that is, that's what 2014 is all about for data, at least the start of that. I think, anecdotally, I was about to say, like, we'll hear more in the venture capital session. I might ask these questions myself, but anecdotally, I've seen a lot of people, a lot of interest from the venture firms, the people that kind of get the space, they need to start investing, and they're investing in verticals. And in my notes, I have a link to an article about this. But people are investing in verticals. They're looking at marketing, or they're looking at a specific domain where they help solve the problem you're talking about, which is a marketer needs to know what's going on, and without development help. Or whatever, like a retailer needs to know something about their products. This is coming. Unfortunately, we're not there yet, but I think this is going to be the next wave, or this is becoming the next wave. I say that anecdotally again because I don't have stats about this. I don't have venture capital investment stats. But you're already seeing it. I mean, there are companies that are focusing on this space. Some are doing it generally. You'll see, for example, Cloudera, I realized, that's a developer tool, it's a platform, but they're also building new tools that make it easier to do some of the things you're talking about. Just as an example, like a lot of companies are getting in this space. So again, yes, but it's not gonna be here yet. It's gonna take some time, and probably will be proprietary. I think the open source world is lagging a bit on this. Python's doing a good job. I think those guys are doing great. Like they're making something really accessible that is a developer tool, but it's like, it makes sense to the user. And, but I think the open source world's totally lagging behind on this, as you might expect. I'm not blaming them. That's how open source technology works. But it's coming. It'll be here in a few years. Cool. Another question over here.
To add on to the last question, there are proprietary tools that are available today where you have domain experts who are able to ask questions and then select what data sources they want visually and start connecting the dots using algorithms that are in libraries that are now really objectified and putting them onto a palette. We've been building frameworks like that for 4 years now. And in certain communities, it works out really well.
This is, it's interesting that you said you build your own stuff. The other story about this guy, this VP story I told earlier, he did the classic hero thing where he built himself. He built this tool that was helped to predict prices based on usership of the product they were selling. So basically, executives wanted to know, if we get X amount of users, can you help us predict based on past sales, which is not always the best indicator, but past sales, what our predictions should be. And he said, yeah, I'll whip this thing together. And he put something together. And then it became they became dependent on it. So like executives in the company would look at it all the time. And he's like, oh, this is a prototype I hacked together over the weekend. It became this thing they used inside the company. And like it just like indicates to me that we need products like that. I mean, these people want products like that. I don't know about the viability of this particular one. That's a classic thing you see outside of some of these companies that don't have a lot of developers, is someone will build a prototype, it'll be hacked together, and then they're unable to operationalize it, and it just they become dependent on this thing that's of questionable technical merit, or it's just not the right thing. And that's what I mean by closing the loop. Like if the company decides we really need this, like they have to throw some investment behind it, and it's an indication that there should be a product or a technology or something that helps in that space. So yeah, I've seen this before, and it's like I think you're solving. What I'm hearing from you is like you're doing the thing where you're solving the problem by throwing developers at it because you have no choice.
No, actually, we started out traditionally from a research standpoint, built the product, and then transitioned it to product. So it actually is a product that's being sold today.
Ah, okay, well, right. So maybe after the session in the hallway, we can pass out some cards, talk to some people. It'd be great. Sounds like people need it.
I don't do marketing.
Engineer. Yes, question in the middle.
So actually, I want to follow up on that question and comment about open source and proprietary. Based on, I don't know, your observations of the history of other open source projects or areas, what kind of things do you think are needed to make open source more attractive for some of this tooling?
Oh yeah, I mean, I didn't mean to say that it wasn't attractive or completely necessary. Like it's just that to solve the end-to-end data pipeline problems, the tooling is very bad for A to B, or more specifically, A to B to C to D. So in the wild, right, you see people. I kind of had this example earlier where I said, oh, I took data from this non-relational data store, I put it here and I put it here. And all of these things require very different tools with very different descriptions of the data, different schemas, different requirements. One needed a cluster, one was a single node, one was an API. I mean, like BigQuery is an API. Hadoop, I was running on a cluster in Amazon, and my non-relational data store was just a server I had. And like these are all very, very different technologies. And the thing that was missing was ease of use to put them all together. And I think the reason is because in the open source world, oftentimes a tool starts as a way to solve a specific problem. Like Hadoop is a tool that I need to run MapReduce jobs. I need to do MapReduce jobs over large amounts of data. It wasn't meant to be a non-relational data store. It wasn't meant to be a machine learning tool. And yet the ecosystem eventually threw this stuff on top of it. And that's the case. And so people are quickly putting things together with these tools, but they're realizing that, oh God, I wish I could just change the schema or just remodel my data. If I want to take my static data and put it into an analytical database, I might want to remove a column, and that's tremendously hard to do in some of these cases. So those are the kind of tools I think would be useful. The Apache Foundation has been doing a pretty good job, I think, of trying to rein it all in. And not ironically, I guess their name of their tools, like things like Zookeeper and Yarn, and they try to rein these things in, and that's good, but it's come late. It's come late, I think, and I think which is fine. And this is how technology works, nonetheless, right? Like things have to get started and grow, but we're facing this problem where now everybody wants to use it, and everybody is realizing they have these problems, and because of the disruptive technology coming from competitors and from this onslaught of things like social media data and logging data and ads data, people are like, I need this now. I need to do this now. And unfortunately, there's just not a lot of open source tools for doing that. I mentioned IPython as a good example of a tool I think is great, where it's set up in a way that allows me to share and to have things in one place and to bring in different technologies and show graphs. And it kind of matches the way that people work with the data. And I like that a lot. I think we need more tools like that. And I think data people in the open source world would do a good job like helping to smooth that over, driving adoptions tremendously.
Yeah, I do see what you just mentioned on proprietary technologies happening within Kaiser as well. Kaiser recently invested on a company called Health Connects, I believe.
Health Connects.
And it's public, so I'm not leaking anything here, but yeah,
I'm going on TechCrunch right now.
It's a proprietary technology that they have for data warehousing, specific for healthcare, obviously. And I think one of the things within healthcare is there's quite a few healthcare companies that use Epic backend system to store the patient-related data, EMR. And so that's one of the things within healthcare is that proprietary technologies can easily be tailored to integrate with Epic in this case, right? And specifically work toward the data that is the data pattern that is similar among healthcare's
right.
companies.
It's interesting. Like this is an example of a vertical where people are attacking the vertical with a particular product, maybe just for healthcare.
Right. So I guess part of my question is: do you see that technology trend is being focused around data analysis on specific industries, like healthcare might be has its own proprietary technologies?
It's funny. I don't. So maybe I'm out of the loop on the healthcare venture funding, but I don't know much about it. I feel like I don't hear about it because there's not enough of it. Or maybe the problem is so messy and dirty that people don't tend to invest in it. They're like, marketing, I'll invest in that because I understand it. And retail, I understand that. Maybe healthcare is just too much of a can of worms. Although, wow, what an opportunity. And I'm sure there are more that I don't know about. But yes, the trend that I'm seeing, and I think I've heard a lot of people in like the big data glitterati talk about this, which is like, we spent time the last couple of years trying to figure out what big data was, what the myths are, when does it work, and it's like finally people are just taking a break and going, okay, what are the problems we're going to solve? Marketing, and there's people like solving these marketing funnels, and like Google Analytics is a good example of a vertical that just attacks analytics. Over the years has become a product that's pretty self-service for that vertical of like, I want to know who's coming to my website. And I think I'm not very familiar with the product anymore, but they're doing that kind of thing. And yes, so I'm sure there's more of it in the healthcare. It sounds like if I was Kaiser, it's like, and they're probably doing this, but like Kaiser should be investing in some of these startups. Like Kaiser should have a venture fund that's like, look at this problem we have. Let's throw $12 million at it and see what happens. I think there's a great opportunity for that.
Yeah, that's the approach that
really
organizations taking. We do have a KP venture, and that's one of the companies.
There's one. Okay. Yeah, I'll do a little research later and then learn about it. I feel like I just don't know enough about healthcare. Although, man, what a big field that needs a lot of help. Great. So, any other questions or comments or interesting use cases, or want to talk about something else? It's great to see so many people. Some people I knew from my high school days. It's been a long time. I see like a lot of people here. Himiko's here. It's good to see you guys. So yeah, I mean, I think we're getting close to the end. Should we maybe wrap up and have a break? If there's any other questions, let me know. Good. All right. Well, enjoy the DataEDGE conference, everyone. I'll be in the hallway.